Welcome to Algaeomulus Prep Academy. Today's lesson is finding volumes using the washer method revolved about a line. The regular equation for finding volumes revolved about the x-axis is volume equals pi times the integral from a to b of big R of x squared minus little r of x squared dx. This can be broken up into the equation volume equals pi times the integral from a to b of big R of x squared dx minus pi times the integral from a to b of little r x squared dx. The regular equation for finding volumes revolved about the y-axis is volume equals pi times the integral from a to b of big R of y squared minus little r of y squared dy. This can be broken up into the equation volume equals pi times the integral from a to b of big R of y squared dy minus pi times the integral from a to b of little r of y squared dy.
Problem 1. Our two equations are y equals fifth root of 128x and y equals 0.7x, and they are revolved around the line y equals 4 in the first quadrant. The stick figure is on the line y equals 4 because that tells us there's a hole in the graph because this integral is going from top to bottom.
We find big R of x by finding which function gets completely revolved first. We see that y equals 4 is the top and y equals 0.7x is the bottom. So big R of x equals 4 minus 0.7x. We find little r of x by finding which function forms the hole in the graph. We see that the hole's top is at y equals 4 and the hole's bottom is at y equals the fifth root of 128x. So little r of x equals 4 minus the fifth root of 128x.
First, we find where these two functions intersect by setting them equal to each other and solving for x. We get two values for x equals 0 and x equals 5.2532727. These will be our bounds for integrals. We take pi times the integral from 0 to 5.2532727 for 4 minus 0.7x squared minus pi times the integral from 4 to 5.2532727 for 4 minus fifth root of 128x. This is because in the graph y equals 0.7x is always above y equals fifth root of 128x from 0 to 5.2532727. We get 95.643497 for the first integral and 18.87411311 for the second. And after subtracting the two, we get 76.819386959, which rounds to 76.819.
And here's the revolved graph.
Problem 2. Our two equations are y equals negative x cubed plus 4 and y equals 0 revolved around the line x equals negative 2 in the first quadrant. There is a stick figure on the line x equals negative 2 to show there's a hole in the graph. First, we solve the equation y equals negative x cubed plus 4 for x and set it equal to 0 as the other equation is equal to 0. We get the cubed root of negative y plus 4 is equal to 0. After we solve this, we get y equals 4. This means our bounds for the integrals are 0 to 4.
We find big R of y by finding which function gets completely revolved. From earlier, we convert y equals negative x cubed plus 4 into x equals the cube root of negative 1 plus 4. From the stick figure's perspective, we see that x equals the cube root of negative y plus 4 is the top and x equals negative 2 is the bottom. So big R of y equals the cube root of negative y plus 4 minus negative 2. We find little r of y by finding which function forms the hole in the graph. We see that the hole's top is at x equals 0 and the hole's bottom is at x equals negative 2. So little r of y equals 0 minus negative 2.
We take pi times the integral of the cubed root of of negative y plus 4 minus negative 2 all squared, rounded from 0 to 4, minus the integral of pi times 0 minus negative 2 squared, also bounded from 0 to 4. From this we get 129.108256 minus 50.26548,246, which equals 78.842735, which runs to 78.843.
And here's the revolved graph. Thanks for watching Algaeomulus Prep Academy. Make sure to like and subscribe.